welcome to yet another IoT Plus network and one of their coffee breaks editions, this time within agriculture. We are joined by three amazing speakers here today, but before we dive into who they are and what they do, I'd just like to briefly introduce myself. My name is Tayla. I work at Motion Lab Berlin, which is a high-tech innovation hub and makerspace situated in Berlin, and we are home to numerous different startups, but also corporates working within IoT technologies as well. And thereby we are also part of the esteemed IoT Plus network, and have been able to benefit from the knowledge, the network itself, but also in collaboration with IoT Plus Network, do have a talent program that is designed to educate young individuals within IoT, both in theory and in practice. So it's quite nifty to be joining on that. That being said, today we are going to be hearing from Martin Peter from Lite+Fog, as well as Julio Pastrana, who is the co-founder of Escarda Technologies, and finally from Ferdinand Kemmeth, who is head of efficient communications at Fraunhofer Institute for Integrated Circuits. So that's quite a mouthful. I definitely want to hear more about that. As to the rules of today, it's pretty straightforward or simple. Martin will kick us off by presenting Lite+Fog, what they do, what makes them special, particularly focusing on the technologies. And then we'll have this followed by about 10 minutes for you to ask questions, dear audience. So this means you just need to unmute yourself or raise your hand, and I will then ask you to, or give you the floor to ask your question. And this process will be then followed by Julio with Escarda, and then finally Ferdinand introducing his technology, the mioty, if I've pronounced that correctly. So without further ado, Martin, would you like to kick us off?
Yes, hello, thanks everybody. Hello everybody. I'm Martin, co-founder and CEO of Lite+Fog, and what we do is easiest to show, and you have the opportunity to have a little tour in our facilities here in Marzahn in the Motion Lab. And basically what I will talk about is all about this technology and what it leads to. And what I mean by this technology is, if I'm quick, easy to see, we grow plants, but on textiles and with fog. And that looks a bit like that. We have a fine fog that is created by ultrasound. It feeds the roots on the inside of a hollow tube that is made of textile. In short, that's the technology. Of course, there's much more, and we're going to talk about IoT today. So the IoT part is more or less everything around this plant that I just showed you. And prepared a little presentation. So just to have some illustration of what I'm going to talk about. And yeah, hope you have some questions when it comes to that. So without further ado, like you just said so nicely, let me share this. Now I have to just see how to play. Okay. So a deep dive into IoT agriculture. We're Lite+Fog. We have a large network behind us. Motion Lab is obviously one important part of that. And the technology, everything we do is one thing, but I want to keep focus on the digital transformation of agriculture, and what I think at least is the vision and the result of such a transformation. So to give this a title, I want to call it connected growth. And I think the connection between farms is the one thing that will transform this world the most, actually. So first, what do I mean by IoT and controlled agriculture? Of course, the first thing is control. Controlled agriculture means that we have all the parameters that are normally important for agriculture are always important, like weather, climate, fertilizers, watering schedules, and so on. We have it all under control. I think that's a quite understandable thing and quite easy to develop. And in my claim in the beginning, or if somebody read my sheet before, it's a very underdeveloped field in agriculture. So some sensors, and you're already quite innovative, whereas when you compare it to automotive, we're lacking actually far behind in development in agriculture. But let's say the first step is control. So we basically just know what's happening and we can control what's going on. At least in our controlled environment system, that's the case. Then of course, diagnostics, it's a bit linked to control. How is it going? What's going wrong? Is there anything you have to adjust? Is there an event that disturbs your growth? And then the last part, but probably the most promising and the most important one is prediction. Obviously, in those times, we're talking a lot about ChatGPT, AI. So it's the perfect example where AI can solve problems that humans couldn't. Plants have a certain, well, code, DNA code. But the problematic is that you have about 50 parameters that can be involved in the growth of a plant. And a few of them would be temperature, lighting, wind, somebody broke a stem at one point. All these things obviously change the growth of a plant. But it is precisely there where AI can help, because we're faced with an insurmountable mountain of data, and we have to find patterns in that. That's exactly what AI can do really good. And of course, the basis of all of this is the right sensors, the right metrics, the right control and observation of what's going on. So the holy grail of IoT, I would say, is prediction. Imagine that you can grow a plant in a simulated way, just like you develop cars or anything in a simulation before you actually test the prototypes. When it comes to wind and everything, like we're pretty, have a firm grasp on the physics when it comes to that. We don't know a lot about the plants, not that we don't know the principles, it's just too much to handle at this point. So IoT can really change the way we can look and actually analyze growth of plants. And of course, and that's the next part, we can share this knowledge later on. And I will also explain why we cannot share today. So one side step here, when I'm showing you this little farm, I want to make sure that you understand that plant and agriculture is not only food, it's also medicine. Especially in our case, we're focusing on that heavily. So you can grow antibodies, medication, diagnostics, mRNA, and molecules, just a few examples in plants. And that's going to have a huge impact on the way we do medicine, cosmetics, and other things in the future. We also have those problems that need to be solved with supply chains, pandemics, weather changes. All of this is basically not under control so far, and we can change that. So just a little side note here, vertical farming or farming in agriculture is not food per se, it's actually a lot of other things as well. One anecdote, for example, we met somebody who was growing rubber out of plants to be processed in tire production later on for the company Continental. So it goes so far as touching lots of industries that we don't even know of or that we're not aware about. What do I mean by connected growth? It's basically important to see that today, when you find out something, how does it grow best in, let's say, the Netherlands? It's not really viable knowledge for some farm in Israel or India or China or South America, because you have different suns, different conditions, different soils, different working conditions, and so on. So basically today it's very difficult to find out a general knowledge about plants and apply it to farms in a uniform way so you can predict what's actually coming out of this. But when we have farms that are basically controlled boxes, so they're independent of their location, we can find out, for example, how to grow something 2% better and share this knowledge immediately with all farms around the world. And it's really, again, independent of where they are. 2% is a huge number in agriculture. That's, for example, when you refine a recipe of a plant, you find out some temperature works better or not. And all of this data can be, like I said, immediately shared and used in other farms around the world. And that makes it a whole different business, I would say. Another thing that I see would change from the part of IoT is actually the contact to the farmer. Like nowadays, you probably never picked up the phone, called your farmer and asked if you can grow something for you, because he has his growth schedule for next year. He has to grow something that grows around here. He has to grow something that he thinks people will buy. So he will always have a portfolio of 8 plants that he will grow to likely sell them. On the other hand, when you have a farm and you can grow every day, everything new, and you don't have an extra workload for that because the farm can be automated. You can take simple orders by people and they can ask you, can I have Japanese cress? Can I have some sort of small rucola? And it's not really difficult anymore to actually take that order and grow it every day. You have basically a product sheet that you grow. So the farmer himself changes his job. So he's not a risk taker anymore, that he can grow only what's likely to grow. that he has to hope the weather is right for it, and that he has to hope that the market will actually have a demand for it. In this way, he's only fulfilling demands that the market is already asking him, and that not next year, but on the next morning, theoretically. So that will change a lot about how agriculture actually works and how we communicate in agriculture. So in short, to summarize, because I think I have 2 minutes left, there's a lot of impact that IoT will do on the whole topic. So the farmer is actually going from a risk taker to a service provider. He basically has a knowledge, he has a capability, he has a skill that he's marketing. He has a farm that can grow whatever you want. I say whatever you want, trees and cereals are probably not part of it, but lots of plants and lots of different use cases, like I said at the beginning, also for medicine. So he's basically becoming a service provider. That makes his job much easier, and also the margin much bigger, because he can actually react to demands that the market has in real time, more or less. For the researcher, it means that from a local relevance, they switch to a global relevance, because when you research something, you can actually market it, or it helps people all around the world, because they have machines that you know how they work, about how they work, and you have complete control over them. And from the customer side of view, it's also changing a lot, because you gain a direct access to your producer. And that's obviously having a lot of social impact, and a lot of business models can be basically based on that you have basically your cloud farming or other services where you order your custom designed food, let's say your restaurant or hotel chain, or just a private consumption person. Also, when you think about supermarkets, you can directly link what they're selling in herbs every day and tune the farming to their needs. So for example, they realize there's an extra demand in basil, it's May, so let's switch our composition of farming of how much basil we put out, and we lower a bit the amount of rucola, for example. So all of these people, everybody involved basically, has a lot to gain from more control and oversight and analytics. And as a little extra, but obviously it's important, we have no pesticides, no shortage of food. We have a much reduced CO2 consumption because you can grow just around the corner. That in turn has a much higher improved sustainability, because you don't need package and you don't waste on transport chains. So all of this obviously is also down to IoT, because we have complete control over farms and we don't need to fight insects. They wouldn't come in anyway. So in short, in 10 minutes, this is what I see as the impact of IoT on agriculture.
Fantastic. Thank you, Martin. Give it up for Lite+Fog. Jumping off now into the questions. Rules of the game, just raise your hand and then I'll open the stage for you to ask. But in the meantime, Martin, I mean, I learned something new about Lite+Fog every single time, so thank you for that. I would like to ask, what does this now mean for you in terms of your next steps?
Our next steps is actually setting up a network, like I was streaming and talking about. So we have customers that are mostly global, like the next customers in Israel. And it was a pure necessity that we had a project in Switzerland during the pandemic, and we didn't know exactly what's going on at the customer's side. And somebody took out the plug of the machine, and I just got a call, the machine is somehow not working anymore. So, and I had to fly down there and realize there's just a plug out of it. So all of this is the first step, where you see, okay, customer relations in a global world where it might actually happen again that we can't travel so much. You need control, digital control. And then on the other hand, if we can control the whole machine, the customer doesn't have to know anymore how to do that. So basically we can offer the service of growing stuff for him, and he just has to harvest. So in the end, it impacted a lot our whole business model, that we also switched to service. That skill is basically programmable in our ways, like we have recipes for certain plants and we can employ them in your machine without having to need to have a green thumb or anything. So that's our next step.
Very exciting. I mean, are there any questions off the bat there? I mean, Will, I see you sitting probably next door to me right now. If there's not, then I'm going to jump in with one more question that I do have for you, Martin. I mean, I know you come in different sizes. Do you want to maybe elaborate on the different spectrums on which your product is shown?
We like the one thing that you saw right now is our smallest model, more or less. This is kind of a research model where you have like a camera scanning the plants and AI working on it. This is basically for research and our own purpose to find out more about the technology and how plants react to this nebula that I was showing in the beginning. And the next up are two bigger models. Like Model L is basically a 20-ton production size per year. And that's a modular system that you can put on your parking lot if you want, and it starts growing those amounts. And this is for pharmaceutical production especially. So this is what we're developing right now with an Italian-German engineering company that also works for BioNTech. And it's actually geared towards molecular farming to be used in mRNA production in the future. And the biggest farms that we hopefully in 5 years from here are actually planning are 1,000 square meters, and they produce 20 tons a week. And that would be more the size for retail, Lidl and Consortium and Co, where you can actually start feeding populations more or less. But this is a scaling of our technology. And with it, every step of the way has a different kind of use case, let's say. But it's just the size of it that demands if it's a research object or a big farm. But on the good side, even if you have a small module in the future and you have big farms that are users basically of the technology, with a small module, you can work on your plant and be the best at it, and then market this knowledge to the big producers. And that makes even small modules very valuable in the future, that you can basically sell your recipes around the world. And just in imagination, if you get 1% of the profits and you have millions of tons being produced, that's a lot of money. So it incentivizes a lot of research and a lot of optimization that today is kind of worthless.
Fascinating indeed. I mean, you've got a whole expert here now in the room with us here today, Martin, of various different IoT experts or people interested within IoT. Is there any current challenge that you would say, hey, anyone in the network able to support with?
I would say yes. The most exciting one is obviously AI. We have a problematic with plants. It's that it's a very difficult object to scan. I can hardly imagine if there is any more difficult one. Nowadays, AI and recognition is a lot of face and cars and let's say simple geometries, to put it this way. With plants, you have a lot of occlusion and you can hardly see all kinds of the plants, even if we rotate them, which in our case we do. So you need a lot of enhancement when it comes to AI or actually other methods and lighting and sensors to complete the picture that you have of the plant. This is a very difficult topic. And it's also super exciting because the whole topic of algorithmic botany that came up in the 1970s, people realized, okay, there is a kind of code in every plant. A lot of computer game programmers know that you find a kind of shortcut to make something look like a tree. And it's mostly 3 to 4 simple rules. And the holy grail that I was talking about is, can you actually conceive an AI or a technology that looks at the plants and infers or reads the rule out of it? Can it realize what is a basil in essence to allow me to type in, let's say, what would basil do if I have a temperature of this, fertilizer of that? And then you have kind of a prediction, in the best case, with 95% security, it will grow better or not. And that would reduce your trial time that nowadays is 1 to 2 years. Like you have an idea, you test it, you have to grow the plants. It takes 3 times. It takes a lot of time. You have to grow it multiple times. So all of this is very time consuming. And if we can shorten this, it would help us a lot. Also in conventional agriculture, of course.
Definitely. Well, if any of you want to know more about Light+Fog or want to pick Martin's brain, by all means, do check them out online. Their website is lightandfog.de, I believe. .com.
No, com.
Well, maybe Martin, could you just type in the chat for everyone to just link up with you? I think that would be easiest. That being said, I am very grateful for you joining us here today and would like to now also open the floor for Julio from Escarda.
Thanks.
Can I start?
Yes, go for it.
Okay.
share your screen if you have a presentation.
Yeah, thank you very much. Are you able to see my slides? Yeah, okay.
Yes, we are.
Okay, my name is Julio Pastrana. I am CEO and co-founder of Escarda Technologies. We are relatively a young company. We are also based in Berlin, Masan. And well, before that, we were a research project for, I mean, the whole project, it's already alive for, I don't know, 12, 13 years. And, but let me first, what is to present you the problem. Conventional agriculture at the moment is, it's outdated. The excessive use of chemicals has devastating effects on our environment. And now the people or society is starting to realize this. We are starting to pay attention to what we eat, and we want more better quality organic products that damage also the environment. In the essence, this is the problem, and a solution is, of course, to switch back to organic, so agriculture or sustainable production of or products of crops. But this, of course, has many challenges. It is not as easy as one think. One of the key problems, for example, is weed control. This is a problem that has always been there. And if an organic producer wants to, carry out the task of organic of weed control, he has to hire a fleet of people that go to their fields and start hand weeding. There are also mechanical approaches and many different approaches. All of them had advantages and disadvantages. And for example, some disadvantages of the manual weeding for people is the costs. People has to be hired, and the wages are increasing every year. Lack of labor. No one wants to be there 12 hours, 13 hours a day in the sun, under the sun. It's a very hard job, and it's very intensive. I don't know if if someone of you has ever been in a field for 12 hours trying to perform this task. At least I tried a couple of times, and I didn't reach the 10 hours that the workers are able to do this task. And it's a very demanding. So this brings us to the technology that we are working on. It's a laser-based weed control, which is based on three steps. We have a camera system, a camera that is traveling or is moving through your field. And every single frame is analyzed by a computer, and it's classified. And then the computer is going to tell you, or the AI is going to tell you, this is your crop and this is your weed. So after the classification is done and the positioning, then we ignite the laser on the plants that we don't want. In this case, all the weeds. So how this AI looks like. For example, this is an example of tomato plants. On the left side, you have the original input, the original is it working? Let me see. Let me move it forward. You have the original video footage, and then on the right side, you have the small dots, the white dots, which are the weed detections, and where the laser is going to be targeted at. So this is, for example, tomato. We're working with a big company in the States. It's a customer from us now, and their idea is to move towards organic tomatoes. They have huge fields, and the idea is to improve the health of first the product, the quality of the product and the health of the population. Let me move to the next example. This is a sugar beet or Zuckerrohr. Here, in this case, we're working with several companies in Germany. I don't know if you have ever heard about Nordzucker, and they produce a lot of the sugar that is used to, I don't know, many products like candies and sweets. I don't know, you name it. And the idea, of course, is again to produce organic sugar beet. So also, why the demand of organic products? I don't know if you have noticed, there's a lot of social pressure to the politicians to stop all the chemicals and all the devastation of our fields and the water pollution and all this. This thematic is growing and growing and growing, and I think in a couple of years, the band is gonna be it's gonna reach. It's gonna be finally there for the whole European Union, and we are looking for solutions, and this is one of them. So after we have this AI, we train it with different crops. The idea is to use what is there. Of course, you can produce a robot and everything, but the idea is to start scaling the technology. First, let us use what is there. In this case, tractors. We put our technology behind the tractor, and we use modules which are gonna be scanning every row crop and taking care of the weeds. This is, for example, one of the tests we made last year in California. These are tomato fields. It was very intense, very hard job, just to be there 12 hours a day. And also we tested it at night because the technology has to work day and night, because we're talking about, I think just tomato, they have 60,000 hectares. So that's a lot area to cover. So it has to be 24 hours. The system has to work 24 hours. So in the end, this is the system we're going to be testing in a couple of months, also in California. It's a 5-row system with many lasers. And as you can see, it's a very lightweight system. Also, I wanted to show you, what's the laser, how it looks like. Yeah. For example, this is how it looks when you are within the chamber of this the laser system. So these are high power lasers, and when you shoot them to a small plants, that's it. That's the idea. You start weeding when the plants are small, and then you will kill them. You are not going to let them grow. This is, for example, the system in action. Yeah, it doesn't shoot at your crop. It always targets your weeds. This is a top view of the system. It's always finding it gets really close to the plant. Sometimes it knocks down one of your or 2 leaves of your crop, but that's fine. The goal is to have the area of your plant clean, so it doesn't have to fight for the nutrients. These are some of the effects of the lasers on the weeds, and as you can see, yeah, we are burning them, and there are weeds that are very resilient. For example, this one is a morning glory, and it actually doesn't die because the roots are like 20-30 centimeters deep in the ground. But the idea is to give a head start to your plant, so it grows faster, and it grows healthier. So these are more examples. We are always targeting the stem of the plant to kill it. And this is pretty much the future. What's next in this year? It's a very small size factor box, like a desktop PC, which is fully functional. And yeah, depending on the grower, they will decide, okay, I need 10 of these boxes, 20 of these boxes, and they can expand. As you can see, this is just a small video so you can compare desktop and then the reading system. And then these are some economical benefits. The system is very lightweight. It prevents soil compaction. It kills weeds really close to the plant. The boxes allow the grower to select as many as they want and to position them the way they want. And of course, it's accurate. It prevents, of course, the use of chemicals, which is the key factor here, or the key idea. And this brings me to the end of the talk, right on time, or a couple of seconds later. But yeah, if you have questions, just tell me, or if you can send me an email, if you want to send me an email to ask me, I will be glad to answer you.
Perfect. Thank you so much, Julio. That was very fascinating indeed. Off the bat, are there any questions for the Escarda team? Tom, you've got a question that you'll just need to unmute yourself.
I do. Hi, thank you so much for the presentation. This has been fascinating. I'm very curious, looking at the system, do you have any idea on, I mean, obviously this is a lot better for pests and pollinators than pesticide, but do you have an idea of what the impact is? Because we're obviously talking about kind of radically reducing the biodiversity in the area, and what impact that has on pollinator or pest populations.
Your question is if we can target also pests?
Oh no, just what impacts the laser weeding has on pests and pollinators. So basically, how this is affecting the insects.
Oh, okay, yes. When we tested it, it has effect, of course, mostly at night, because when we use artificial light while moving through the fields, and of course the insects are thrown to the light. If the insects are in the vicinity of the laser, they die. They will be burned. Yes, but we noticed it was a minimal effect. I don't know if you have read some documentation or some papers about the effects of chemicals on the fields or on our environment. I don't know if you travel, if you realize now when you take your car at night and you travel through some fields, you don't get any more the insects on your windshield. You have to notice that. It's very 20 years ago. 20 years ago at night, you had to use your windshield wipers to be able to see something. At the moment, it's very, very hard to find insects. But to answer your question, yes, it does. I mean, mostly at night. But we are shooting, let me tell you, 40 milliseconds really fast. If we find, if by coincidence an insect is within this 20, 30 milliseconds in the path of the laser, yes, it will die, because it's a high power laser, yes.
All right, thank you. Thank you for the question, Tom, who's also one of our insect experts in Motion Lab. So by all means, also reach out to him. Will, you've raised your hand next.
Sure. I'm wondering kind of how the hardware is going on development and what your challenges are on the hardware side.
Oh, there are many challenges. For example, in the AI area, I can tell you one, which is very, very, it's actually annoying us. That's the word. It's because to train a really good system, you need a lot of images. You need a lot of the whole time where you want to protect your crop. And of course, the labeling alone is the labeling of the images it's very time consuming. It's very demanding. But I mean, once it's done, you have an AI ready to go, and yeah, it works. Another challenge is, of course, increasing the speed. Now we move slow at the moment. We are around, I think this year we're gonna reach 1 meter a second, or probably a little less because a meter a second is already fast, a little less, but we are trying to increase that because, of course, the growers, they want to go faster. Yeah? They have in their mindset laser weeding can be like a spraying, to just move at 10 kilometers an hour and open the sprayers, and that's it. This is a finer thing, and it's challenging. With time and speed is going to come, but yeah, this is one of the challenges. Increase the speed. Other challenge, which is also very yeah, we're still working on it. It's the safety around lasers. Safety in the European Union and mostly in all countries are treated as weapons, or are very or things that can damage a person. So basically the eyes, and that can burn you. So it is required to have safety around it. So we need a safety concept. I can have the best AI, I can have the best shooting system, but if I cannot reach the goal of having the safety concept, I cannot sell it. So this is one thing we're working on. This year probably we're gonna have it ready. And one thing I can tell you, there are some competitors around also doing laser-based weeding, and I don't know if they don't realize how dangerous it is to make demonstrations of the lasers and they open their machines and they start shooting, and there are kids around and moms, and they're looking and they let them do that. And I was looking at it, I was like, oh my God, and it's high power laser. You just with one, you lose an eye, and that's it. Or the Streuen, how do you say it in English? The diffusion of the light, it's also damaging. So these are some 3 challenges that we are facing at the moment, but we're working on it.
And I'm sure there are challenges you can overcome. Now, before we find out if Ferdinand also has, like Lite+Fog and Escarda, the challenge of training AI, Sebastian, you still have the last question to ask for Escarda.
Yeah, thanks, Julio, for the insights. I was just wondering what the regulatory hurdles are to bring laser to the market. As you said, it's almost important, the safety concept. Yes. Is there any guideline? Is there any guideline you can orientate?
Guidelines? Not really. I mean, what can guidelines? I mean, if you part from a normal laser laboratory or where lasers are used, they have to be sealed, and if some person gets into this area, then the laser has to be shut down. So those are the basic rules of the game. Yeah. So those have to be also in this system. We have to prevent that people comes too close to the machine. We have to detect people. This is something, and also have to cut the power of the laser. We have to put our curtains around and everything. But guidelines, since it is new, when I talk to, let's say, to the Genossenschaft here in Germany, they are also like, I don't know, you're the first one who's trying to bring a high power laser to the field. And of course, since it has to be semi-open because the plants have to come into the chamber and then out. Yeah, they are like, oh, there. But yeah, I think the key will be people detection and safety distance around them. Yeah, that will be the key.
Sounds like one of the main frustrations a hardware startup has when trying to enter the market with an innovation. Right. Well, thank you, Julio, for your presentation. It's been lovely to hear from you. I'd like to give the floor to our final speaker tonight, or not tonight. My goodness, it's only what, midday. I'd like to give the floor to our final speaker, being Ferdinand Kemmeth. I'm sure you've got some great insights that we can all learn from.
Thank you. So let me share my screen. Yeah, good afternoon. I would say not from Berlin, from the very sunny Nuremberg at the moment. And my topic will be to present you mioty as a sustainable communication protocol for monitoring and controlling tasks. I have three main topics I want to present. One is motivation of the whole topic. I want to focus on the wireless connectivity, and at the end I want to show the project results and give you an outlook. So concerning the motivation, we have had an internal project and we had two main topics. One was that the irrigation is a major issue for municipal utilities. In this case, it was the Stadtwerke Erlangen. And there are three topics. So the first topic was the plants should be irrigated according to their demand. So it was a question of optimizing the process of the personnel. Then it was the topic of heating up of the urban scenario in the context of the global warming, and it was the green image of the city. And a second big thing was the demand-oriented irrigation and fertilization, which is a future topic in our understanding in the agriculture. So that was a question of optimization of the area yield. So let me give you an overview of the project. The project took part in the so-called Knoblerslander region here in northern of Nuremberg, not far away from the airport. Here on the right, you see the airport of Nuremberg. And there we implemented the whole IoT chain. So we started with the sensor technology, communication, we did the data aggregation, modeling, analysis, and so on. And what we did is, so in this slide shows us the whole IoT chain of the project. So we started the sensor side, we did the communication, and then you need some base station to receive the information. You need some platform to analyze the data you have received. You want to visualize it, and at the end you want to improve the process of the customer. And what I want to concentrate today is the topic communication. So how the connection between the sensor and the base station was done and will be done. The wireless connectivity, and this slide shows us an overview of common wireless communication technologies, which differ in range and in power efficiency. So Wi-Fi, you know it from your home and your mobile phone, is limited in range and limited in power efficiency. If you want to increase the power efficiency, you can use Bluetooth or Zigbee, which is still limited in range. If you want to use a long-range communication, you can use the cellular networks 4G, 5G. And if you want to target both, so high power efficiency and long range, there's a new kind of communication class. This is LP1, low power wide area network. And if we go more in detail into these LP1 technologies, you can distinguish between private and public solutions and proprietary and standardized solutions. Private solution means that you set up your own base station, your own infrastructure. and yeah, you receive your information on site. And proprietary solution means that it's a manufacturer-specific solution. One player in this field is the LoRa protocol, which is focusing on private network, and it's owned by Semtech, a chipset manufacturer. If you want to go to the public, so if you want to use an existing infrastructure, you can use the Sigfox network. So there is a network available in Germany. You can use it, the existing base stations, in order to connect your sensors to it, and all your data will be forwarded to Lucid France, and then you can read it back from the cloud and yeah, do something with the information. On the other side, there are also standardized solutions, the cellular networks, LTE-M and narrowband IoT. You're using, of course, the public network of the cellular providers, and these are standardized within the 3GPP standard. And on the right top, there will be the mioty protocol focusing on private networks, and it's standardized within the ETSI standard. So, in this mioty protocol, what is the technology behind? It's the telegram splitting, which I want to describe here. On the right top side, you see the transmission of a traditional LP1 system. So if you want to transmit any data, for example, temperature, wirelessly, the communication will need some time to the right, and it will use some frequency band to the top. The problem is that we have to share the spectrum with others. So there might be some interferers colored in this some kind of green. And if this interferes at the same time and at the same frequency, the data will be corrupted, there will be a collision, and the data will be lost. So what we did for mioty, it's the so-called telegram splitting. We added redundancy to the information. We split the information into sub-packets, as shown here on the pattern, and we distributed these sub-packets over time, over frequency. If we now have, again, the same interference scenario, so some of the sub-packets will be destroyed again, but if we get at least 50% of the sub-packets, we will be able to reconstruct the information in totally. It has some more advantages. So one is the robustness, but also it is programmable to many chipsets from several manufacturers, and it is battery optimized. This slide shows us already some overview of the technology. If I start on the right top, the high range, it's the same for all of these LP1 protocols. They are focusing on several kilometers distance. It depends a lot on the environment. So if you have an urban scenario, it is less, of course. If you go through buildings, it's much less. And if you are in a rural environment, it can be 15 kilometers and more. The power efficiency, in our understanding, is very important in this whole IoT scopic. If you want to use IoT sensors, this also depends a lot on the amount of data. So if you have huge packet sizes, you have it's reduced. It's less battery lifetime, of course. The reliability and robustness is very important. One thing I have already showed with the interference scenario, but another thing I haven't mentioned is the self-interference. So the question, how much does one of your sensors influence the other transmission? And if we count with large increasing market of this IoT sensors, there will be many sensors in the same frequency band, and then the self-interference will be very important. And this leads us to the scalability. So with mioty, you can scale up to 3.5 milli messages per day per base station, and this number can be divided by the number of transmitters, for example, in the update rate. Mobility might be not a big thing in the agriculture scenario. but the sensors or the base station can also move up to a velocity of 120 kilometers. All these LP1 solutions, or most of them, work in the sub-gigahertz spectrum. It's 868 megahertz in Europe and 950 in the US. The private network I've already mentioned before, and the standard I've already mentioned. So a short comparison between the different technologies which are might similar to mioty. So the narrowband IoT from the cellular providers, it takes 150 millijoule in order to transmit 10 byte. LoRa is in the same amount of data, and Sigfox is that takes some more energy. So mioty is here really has big advantages there. There are some more benefits. I do not want to go into detail because of the time, but in our understanding, the power efficiency and the scalability are the most important things protocol should support. So the mioty was developed by Fraunhofer in principle, but now, since February 2020, it was the last Embedded World exhibition before COVID came. The mioty Alliance was launched. So it's in German an eingetragener Verein, where several companies are members. We have full members. With chipset manufacturers like the Texas Instruments and sensor producers like Leica, for example, but also many others like research organizations and other companies. All of the big chipset manufacturers are also members there, focusing on the standardization of the higher levels of the communication itself and to ensure an interoperability through the whole IoT chain. Yeah, so the almost last slide, the project results. Let's come back to the first slides. What we did, we implemented the whole IoT chain, starting from the sensor. The sensor is shown here on the bottom left. It was a ground sensor from Aquolution, a small company focusing and providing end-to-end solutions for agricultural monitoring. By the way, this sensor was fed with energy only about photovoltaic cell. It was a very small one in the top. Then we did the aggregation, modeling analysis, and at the end we also, or our colleagues from the business development also did elaboration of service and ecosystem. So one slide to the outlook. So there's just a new project which has just started in the beginning of February, public funded, where we want to develop an, I have called it wireless base station. So we have, of course, the sensors are wireless and they are connected via mioty. What we now want to do is that we also do the base station connection without cable, so no power connection, no wireless connection, because especially in the rural and in the agriculture area, we do not have any connection there. So what we do is some kind of relay and forward the information to the next base station, which is at the end connected to the internet. For partners, beside us, we have WebTech, who does the electronics, Anything, who is expert in the solar cells, and Aquolution, who does the end-to-end solution. Yeah, so I would skip this one. If you have any question, you have now time, 4 minutes left to ask, and otherwise I would be happy if you just call me or write me a mail with your question. Thank you for your time.
Thank you, Ferdinand. Well, Martin, you've got a question straight away. Go for it.
Yeah, hi, Ferdinand. Thanks for that. Sorry if you mentioned it already, but could you maybe tell again what's the bandwidth? Like, can you actually picture and video transmission as well?
So the bandwidth, that's the disadvantage of all this LP1 system, is very low. So they're optimized for energy consumption, several years lifetime, and distance, several kilometers, but it's not feasible that you transmit a video image or any streaming application. It's more like you transmit sensor information every few seconds, once per minute or less.
Yeah. Is it thinkable, because we have most of the data, like 90% is what we have, small numbers like temperature, something very small data bits, but we have also the image, or to create once a day only of a 3-level plan. So we thought about actually employing LoRa, which in your case you have a better option, and that okay, because we have we could pre-process and then just have one image of the result basically transmitted, and if it takes 2 hours, that would be fine. But is that actually 2 hours or is it 20 hours? Like,
yeah, we have to go into detail, but it's a good idea. You have to pre-process it, do some pre-processing on the sensor side, and one transmission can hold up to 250 bytes. You can transmit, of course, and split the information to multiple packets, but yeah, it will take some time.
Yeah, okay, thanks.
All right, just in terms of time, I don't think we have any more time for any more questions, but this is exactly why I love these sessions. Martin, Ferdinand, you two need to connect, it sounds like it. So I think this has been successful overall. On that note, thank you, dear audience, for joining. Thank you for asking your questions. Be sure to tune in to all future IoT coffee breaks. As you can see, they are very insightful. Thank you, Jackie, for organizing this and for hosting it all together. And dear speakers, thank you for sharing your insights, your technologies with us. It has been wonderful to have you here. On that note, have a good evening. Again, good evening. My goodness, what am I wrong with me today? A good afternoon still, and hopefully see you around soon.